In this lesson, I'm working on solving absolute value equations and absolute value inequalities with the students. I'm working on the guided practice, and the absolute value equations are easier for students to work with usually than the absolute value inequalities. But I use that same concept of equal to as a boundary point for students to start with, whether the equal sign is there or not, and we'll talk about that as we get to the inequalities. The first problem in the guided practice, absolute value of x is equal to 10. It's easy for students to see that the inside has to be equal to 10 or negative 10. So that's actually the solution, x equals 10 or x equals exactly negative 10. On number 2, you have, well, if I have the inside is equal to, it's equal to 2, I know no matter what's inside there that it has to be equal to negative 2 or 2. So when I write the expression x minus 5 inside the absolute value signs, I actually can use that definition and say, okay, then I know the inside x minus 5, if I drop the absolute value signs, could be equal to 2, or x minus 5 could be equal to negative 2, and then that would tell me what the solutions or possibilities for x are. I also can use the concept of that it means 2 units from 5, so 5 plus 2 is 7, and that's this equation that you see here that you could go ahead and add 5 and see that it's 7, or 2 units from 5 also would be 5 minus 2, which is 3, and that's this equation that you see, a plus 5 minus 2 is going to be 3. And then the rest of the guided practice goes into the inequalities after a few more equations. So if we look at let's look at number 9. Number 9, the absolute value of x is less than 5. So even though I don't have an equal sign there, I'm still going to use that as a boundary to start off with. And the number lines are easier for students to see. So if I said it was equal to 5, it would be 5, or negative 5 would be the distance from 0, 5 units from 0. So I'm still going to use those boundary numbers, but I know that it's going to be open circle there, that it's not going to be equal to because there is no equal sign. And now anything less than 5 when you take the absolute value is going to be any numbers in between there, because if you took the absolute value of negative 6 on the outside of that, it would be 6, which is still greater than 5, and 6 also on the other side is greater than 5. So any numbers in between there, like the absolute value of negative 1 is 1, so it's less than 5. Alright, number 10, and again they can test solutions. Let's look at number 11. So we have the absolute value of x minus 4 is less than or equal to 3. Again, I start with that equal to sign, whether it's there or not, just as a boundary. So this means that 3 units, all the solutions are 3 units from 4 is the boundary number. And so 4 plus 3 would be 7, and it's going to be equal to that. And then 4 minus 3 would be 1, so it's also going to be equal to that. But to be less than what the boundary numbers are, the final boundaries, it would be in between all the numbers in between those numbers, not outside of the numbers. And then if we look at greater than, like number 13 says absolute value of x is greater than or equal to 3. Well, equal to 3 would be at 3 and negative 3, the 3 units from 0. And then you're going to have greater than, though, is going to be any numbers outside of 3 and negative 3. For example, if I took the absolute value of negative 4, that would be 4, which is greater than 3. So even though those are negative numbers to the left of negative 3, when you take the absolute value of those are greater than 3, so you shade outside of the numbers for greater than. And students will start to recognize the patterns of that, of what's happening. The last problem we'll work together is number 15. Absolute value of x minus 2 is greater than or equal to 4. Again, I'll start with the boundary numbers. 4 units from 2 would be 2 plus 4, which is 6. And 2 minus 4 is going to be negative 2. And again, greater than is going to be outside of those numbers.